from?
Minneapolis.
Minneapolis. Hey, terrific. Well, thanks so much for joining today.
Thank you.
All right, well, I will get started. Just a reminder that this meeting is being recorded and it will be posted to the Linux Foundation shortly after. And your participation in these meetings is an agreement to abide by the Cloud Native Security Code of Conduct, and I will briefly touch on that in a few slides. Overall, I'm Ryan Etten, your CNCF Cloud Native Madison organizer. I work for Red Hat, and with me here is Derek Walker, one of Red Hat's security SMEs, and we're going to kind of discuss proactive security at scale, leveraging Cloud Native security principles. Overall, the primary goal today is going to be helping you understand precisely what Cloud Native security means for your organizations, why it deeply matters, and then how you can integrate that effectively throughout your software life cycles. So while it's meant to serve overall as a high-level overview, the density of the topics that you'll see are meant to kind of reinforce that security is a shared responsibility. So to that end, we'll be exploring how Cloud Native security isn't just about tools and technology. It's a comprehensive approach to covering the intersection of people, processes, and technology. So we'll navigate how developers and technical leadership can identify, evaluate, and then strategically apply these principles effectively to protect and enhance their organization's Cloud Native capabilities. As I alluded to right away, we abide by the CNCF Code of Conduct, which ensures an inclusive and respectful environment. So please help keep our community safe and welcoming. If you face or witness any uncomfortable conduct, just let me know or reach out to the CNCF directly. For those of you that may be new here or watching the recording, founded in 2015, the Cloud Native Computing Foundation exists to support vital open source projects like Prometheus, Kubernetes, and more. And they also host major conferences. Our next one is going to be in London, April 1st to the 4th. And they also empower local groups like ours across the globe. And we share in the CNCF's goal, and that's ultimately building strong Cloud Native communities. So thanks to those of you joining from Brooklyn and Minneapolis. Who are we specifically? We are the community group based out of Wisconsin and the local chapter in Madison specifically. And we've been uniting developers and ops engineers and tech enthusiasts around open source and Cloud Native technologies. Like all of our groups, we emphasize sharing knowledge, fostering those DevOps, DevSecOps cultures, and then staying in lockstep with CNCF's broader mission of collaboration and open innovation. If you want to stay up to date with what we're doing, please join our Slack or mailing list. Look out for our chat and circle announcements. You can follow our link tree, stay updated on meetups, projects, and community events. You can also find our new company page on LinkedIn, join our page on the CNCF community group, and follow our CFP process to submit your ideas and talks to help grow the community. Why should you join? Whether a community here or in Brooklyn or Minneapolis, being a part of these local communities is going to help you connect face-to-face with people that share your interests and goals. And it's ultimately a great way to network, learn, and share your own Cloud Native journeys. In 2025, for Madison specifically, we've organized our local efforts into 3 pillars under the Campfire series. I host a series of chats on the 2nd and 4th Fridays of every month that are just short bi-weekly sessions that are pretty much in office hours to come pop in, informal, no agenda, learn about the group, ask questions, discuss sponsorships, speaking opportunities. And then we have circles. These are going to be the monthly deep dives like we have here today, where we pick key topics, supply chain security, AI and observability, and we dissect it thoroughly. We will host those as we kind of go throughout the year as hybrid events, in person when the community calls for it. But our flagship events ultimately are the connects that we have. And these are going to be our larger in-person gatherings that we have quarterly, little mini gatherings, mini conferences, kind of like a mini KubeCon or Kubernetes community days that you may see. Where we just get together and learn about all things Cloud Native and the amazing communities. To that end, for any of you local or local-ish to the area, I'm working closely with Grafana Labs to sponsor our first Connect here in 2025. We already have about 6 awesome submissions for our talks, and we'd love to hear about your Cloud Native adventures as well. So if you'd like to participate or speak at one of these events, we'd love to hear about any way you'd like to join. All right, so now that I got that out of the way, I want to get to the meat of today. I'll pause here for a few minutes to kind of lay the foundation of today's talk. Imagine your organization has recently embraced Cloud Native approaches. You guys are moving away from legacy monolithic applications toward more modern microservices, and these are being deployed via containers and orchestrated by Kubernetes. Initially, all of your development teams are thriving. Pace of deployment is accelerating dramatically. All of your updates that took weeks now take mere minutes. And the infrastructure is scaling automatically, and agility is your greatest asset. Things are awesome. However, though, the security teams are going to start to face an unfamiliar challenge. Your traditional security monitoring built around stable networks and static IPs and perimeter-based defenses are going to struggle to keep pace. The ephemeral containers are going to spin up, vanish rapidly, and they're each going to potentially introduce unknown vulnerabilities. So visibility into what's running at any given moment is going to become a critical challenge. Essentially, a container that existed a minute ago is going to be replaced by a new version, but those vulnerabilities that were introduced in those transient containers are going to linger and create unforeseen risks. So what that does is highlight why our traditional security frameworks, which rely on those heavily static networks and perimeter defenses, are going to be insufficient for cloud-native architectures. IP addresses, static firewall rules are no longer going to be able to protect your infrastructure where those workloads are changing continuously. So security teams are going to have to transition then from static security models to more dynamic metadata-driven approaches that are going to identify your workloads based on cryptographic identities, roles, behaviors, rather than those physical or IP-based locations. So from an organizational perspective, it's a profound shift. It's going to impact those processes, roles, team dynamics, and influence your developer productivity and overall operational agility. So without an integrated security practice, your development teams are going to unintentionally bypass your security controls in order to keep delivering quickly, and that's going to soon create a lot of friction and expose more vulnerabilities as you work through the lifecycle. So to effectively secure these modern environments, organizations are going to need a paradigm shift toward more proactive security integration throughout the application lifecycle, and not just as a final gate before production, but embedded systematically at every stage. So cloud-native security is fundamentally about evolving your organization's culture, processes, and tooling to align security seamlessly with development, distribution, deployment, and runtime operations. So throughout the presentation today, we'll explore exactly how you can achieve this integrated continuous security approach. So again, let's picture your organization fully embracing cloud-native approaches. Your developers are rapidly delivering hundreds of microservices weekly. You're using containers and Kubernetes automation. Speed is transformative, but security is simply not going to be able to tag along in the end. So the CNCF also offers a structured solution to this. They help you embed security continuously through a clear phased lifecycle. Those life cycles are develop, distribute, deploy, and runtime. And we can reinforce and evaluate tools against standards like the MITRE ATT&CK to ensure proactive integrated security that aligns naturally with your agile development cycles, enabling safer and faster innovation. So as you begin to embrace cloud-native technologies, understanding the structure of the cloud-native stack is going to be essential. It typically includes your foundational infrastructure layer, your application lifecycle layer, and ultimately the runtime environment. And each one of these is going to play a critical role in ensuring scalability, portability, and agility. So organizations that can adopt cloud native through different deployment models are each going to offer a distinct level of abstraction. So while we've seen our traditional infrastructure as a service, which relies on VMs or bare metal hosts, newer cloud native models like container as a service, CaaS, or functions as a service, FaaS, are going to give you greater flexibility and simplicity. With CaaS, the containers as a service, your primary resource is the container itself, and is orchestrated and managed via platforms like Kubernetes. It will empower your teams to build scalable, secure containerized applications, embedding security policies directly within your deployment processes. And then because the containers are platform agnostic, your teams are going to be able to deploy consistently across public clouds, private clouds, even your on-premise infrastructure, and reduce the overall complexity and cost of your operations. Moving further toward abstraction is where the functions as a service or FaaS comes in. And this is going to help let your developers execute application code in response to specific events without handling that underlying infrastructure. So with FaaS, your developers will focus purely on business logic and eliminate concerns about server maintenance, OS configurations, and web server management. The cloud provider here is going to be handling the aspects of automatic scaling and management, and your operations then will only pay for actual usage, further optimizing those costs and resource utilization. All that said, selecting the right deployment model here, though, whether it's CaaS for your container management or FaaS for maximum agility, is going to directly impact the security strategies and overall operational efficiency. All right, so let's step through each of these lifecycle phases a little bit deeper. We'll show a diagram to complement each of the phases intro slides as well. In cloud native security, the develop phase is going to emphasize embedding security right from the start. So this will be in you integrating secure coding guidelines and patterns, such as those that are outlined in the OWASP Top 10, directly into your developers' daily workflows. So by establishing best practices and adhering to industry standards, we're going to help your teams build strong foundation of security that becomes an integral part of their code base. Additionally, we have robust vulnerability management, and that will be key. So we have automated tools like static application software, security testing, dynamic application security testing, software composition analysis, and all of these are going to be integrated into your CI pipeline. Tools like these are going to continuously scan your code and third-party libraries, ensuring that any bug or any vulnerabilities are caught and addressed immediately, just like any other bug or build failure. So not only here will rate remediation, but we're also going to focus on preventing insecure code from progressing further down your pipelines. More importantly, compliance checks are also essential during this phase. So leveraging like the CIS benchmarks is going to ensure that your code, as well as the supporting infrastructure as code, templates and container manifests are all going to meet your strict security standards. Since artifacts are often prime targets for attacks later in the lifecycle, securing them early on is going to dramatically reduce your overall risk. So by incorporating your automatic security checks, dependency management, compliance validation right from the beginning, the develop phase is going to transform security into a continuous integrated process. And it's a proactive approach again that's going to give you short, actionable feedback loops and allow the team to resolve issues confidently and deliver a secure, robust software to your production environments. So let's visualize this just a little bit. As I mentioned, first, we want to integrate security requirements alongside your business and design requirements early on in the development process to help your teams identify and prevent vulnerabilities and compliance proactively. Here we can do threat modeling exercises and highlight some potential risk areas. We can ensure your development teams prioritize high-impact security controls early on, and we can reduce remediation costs and enhance your overall security posture. Secondly, developers must leverage automated security scanning tools, and they should be integrated into your development workloads that are already familiar to you, such as your CI pipelines, your IDEs, your code repositories. And using these tools, we can help you identify vulnerabilities, misconfigurations, compliance violations directly within workflows that you're already used to, and let your developers address security issues immediately rather than wait for the development, deployment, or later stages. So again, it goes ensuring fast, actionable feedback cycles that empower your developers rather than obstruct their progress. Third, a robust testing strategy is going to be essential here. Developers, security, and security personnel operations should all be collaborating closely, writing targeted tests and ensure that your business critical components are all. Take a look at where your high threat areas are and also historically problematic code. Here include infrastructure, database hardening, container configuration, fuzz testing, static DNS integration, smoke testing, what have you. And provided isolated and dedicated testing environments as well are going to help you rapidly test and reduce time spent resolving issues during your productions. Then finally, back to the code review process. Some of you may be familiar with the 4 I's principle. We want to ensure accountability and reduce risk and inadvertent vulnerabilities being reduced at this stage. Code changes can have significant security implications, so making thorough peer reviews are very crucial to proactively maintaining secure code. So together overall, these are proactive security measures. They are embedded seamlessly into your development cycles, and they're going to empower your developers to deliver secure software at speed, reducing risk, enhancing, and ultimately laying a secure foundation for your cloud-native journeys. Moving on to the second phase, we have the distribute phase, and this is going to ensure the integrity and security of your software artifacts in this critical stage. The security of a system is only going to be as strong as its supply chain. So that means that every stage from design and development to distribution and deployment must be secure. So defending the supply chain is going to require rigorous controls over how software and hardware components are created, configured, distributed, stored, and verified, and we need to hold every contributor accountable. As you mature, a mature supply chain strategy is going to start with clear policies that mitigate risk from both first and third-party vendors. We will have digital signatures and cryptographic verification that's going to be applied to source code, build artifacts, and container images, and this will help ensure your integrity throughout the entire process. So we have end-to-end attestation that each stage from code commit all the way to deployment have been securely executed. So if you are not familiar, a key tool in this process is the software bill of materials, or SBOM, which is going to inventory all of your software components using standard formats like SPDX, Cyclone, or SWID. SBOMs, along with the Delta reports generated during your builds, are going to help you pinpoint which components are vulnerable when new CVEs are disclosed and help, again, continue to enable that faster remediation. Visually, the distribute phase on securing that software supply chain. And it's also becoming a growing challenge due to the widespread reliance on open source software and third-party container images today. So to effectively mitigate our risk, we want automated scanning to continuously identify vulnerabilities, malware, and misconfiguration within our container images before deployment. We want to implement digital signatures to ensure artifact and protect against tampering. Furthermore, with secure internal registries with clearly defined stages. And that means a registry such as development, staging, and production to help further safeguard your infrastructure. Overall, the approach will then make sure that those artifacts remain trustworthy, validated, and aligned with the security compliance requirements throughout the entire CI/CD pipeline. Moving on, we have the deploy phase. This is going to be your organization's final line of defense before your application production. And this makes it essential to enforce as many security measures that we can at this critical juncture, because once an application of yours reaches production, the game changes. So this phase here is going to let infrastructure as code, IAC, to validate that security configurations are accurate, consistent, and compliant. So by embedding security checks directly into processes, we can ensure that the infrastructure security policies are consistently being enforced and significantly reduce risk of configuration drift or human error. Additionally, we can deploy admission controllers like the Open Policy Agent or Gatekeeper. It's going to give you automated policy enforcement to your orchestration systems. So essentially, these tools act as gatekeepers, and they're going to validate your container manifests, security attributes, or operational policy. So if any of your deployments attempt to violate these defined security constraints, for example, we have a rootless container, a rootful container with excessive privileges, admission control will block that deployment immediately and then provide rapid feedback for correction. Importantly, observability and real-time monitoring is going to further enhance the security of your deploy phase by identifying misconfigurations or anomalies before they impact your production environments. So using observability tools, you can gain deep visibility into your deployment activities, the infrastructure state, and the runtime behavior, enabling early detection of security and compliance violations by reducing response times from days to minutes. And then best practices, we'll get into GitOps a little bit later with Derek, but best practices like blue-green deployments or canary deployments are introduce controlled rollout strategies that will do additional validation of security and compliance in a staged manner. So these deployments will reduce the overall impact of your issues, and they're also going to give you a safer pathway of rolling back any problematic configurations that you may have. So together, all of these practices, your ISA validation, policy enforcement through admission controllers like OPA and Gatekeeper, proactive observability, advanced deployment strategies will ensure that your applications enter production securely, reliably, and confidently. To an integrated approach that transforms development from a point of potential risk into a state of assurance and stability in your cloud-native production environments. So in the deploy phase, this is where your team is going to perform those critical pre-flight checks before workloads enter production. The checks here are going to integrity, runtime security policies, host compliance, network configuration, alignment with the security and compliance standards. Observability tools are critical. It's going to give you real-time detection of anomalies through metrics and behavioral analytics and give you facilitation for quick escalation and response. And then incident response strategies as well are going to be supported by detailed logging and forensic capabilities that will give your teams the ability to find root cause, minimize exposure, and again, iterate and rapidly mitigate incidents in dynamic and container-based environments. The final lifecycle stage is the runtime phase. At this phase, focus on three critical areas. This will be compute, access, and storage. And the security here is going to depend on the robustness of all of the preceding phases. Develop, distribute, and deploy, and each layer within the runtime environment. That goes from hardware to the host OS, to the network, to storage, container runtimes, and ultimately the orchestration layer. Derek's going to be diving a little bit deeper into these in-depth strategies later on, so hold on. But to set the stage, container runtimes offer various isolation options. So we have shared kernels, micro VMs, sandboxes, trusted execution environments, and depending on your workloads, whether it's on trusted multi-tenant applications, private sensitive data, you might choose VM-based sandboxes or even confidential containers to help ensure your proper isolation here. Applications in this phase are going to consist often of multiple microservices. They're all going to communicate through orchestrated service layers. So best practices here are going to include strict namespace control. You want to apply network security policies with Kubernetes namespace and control groups. monitor traffic, detect unauthorized access, and ultimately real-time threat detection is going to be essential. So we have tools like Falco and runtime detection with IDS IPS solutions such as StackRox. That's going to help you actively monitor these anomalies, and behavior analysis tools are going to help further detect new and emerging threats. Finally, implementing a zero trust framework. You've probably heard that by now, but it also applies from cloud first and extends itself into cloud native environments as well. It's also a core principle. There's another thing Derek is going to be discussing a little bit further on in the slides. Overall, what this means, using identity management tools, SPIFFE, SPIRE, mutual TLS, integrating service messages, it applies a default deny strategy as zero trust from a authorization point. So ultimately, it's going to ensure that every interaction that we have is authenticated, it's authorized, and it's encrypted. It gives us that layered approach of creating a resilient runtime environment that's going to continuously protect our assets and storage resources. So I'll end with a rather dense on the runtime lifecycle stage. And this deck will also be provided to you after, so feel free to take a look once I share the post-meeting follow-ups. The long and short of it, though, is in the runtime phase, securing compute resources and orchestration is essential. So we have container-specific minimalistic operating systems that are going to help reduce the attack surface. We also have hardware-rooted chains of trust. We have secure boot, graphically verified workloads. We have our trusted execution environments that can help ensure our sensitive data remains protected, even in compromised environments. And then we ultimately have those orchestrators like Kubernetes that require rigorous configuration hardening, strict resource limits, and real-time monitoring of changes to detect and prevent threats. So the TLDR of that is implementing actionable logging, continuous event forwarding, clear resource management policies are all going to be critical to maintaining the security posture that we need throughout our workload life cycles. So with that, I would like to hand it over to the important of the day to dive deep into the multi-layered security that we have across all these lifecycle stages and start to emphasize the core principles and best practices that go along with it. So Derek.
Well, thank you, Ryan, and thank you for inviting me to speak today. And thank you all for showing up and having an interest in this. Obviously, security is a critically important aspect to providing cloud services these days, needless to say. I don't know about you guys, but that was a lot of stuff in there. It's a good thing you're going to have the slides afterwards so you can do your homework and look at some of those. One word of maybe reassurance is, this is a really deep subject, and we're trying to take a 10,000 foot pass without diving too much in it. So there was a lot of terms there that were just thrown out. You may need to go back and look at them. I do every once in a while, exactly what those things are. But having, let's move on here. So having gone through, Ryan's gone through the cloud native application lifecycle, application security. But of course, that's only one part of your ecosystem. Your ecosystem, as we show in this diagram here, is comprised of many layers, and each one builds on top of the other one. And what this, and of course, you need to have security in each one of these layers. And so this starts to illustrate a concept called defense in depth, where you stack or stage different security controls at different layers to provide a more resilient defense mechanism. And these can be, as far as the controls themselves, they can be redundant controls. You can have like a network control at one layer and then say at your firewall, and then you can have a network control at, say, Kubernetes, at the container. There's numbers of them. The idea here is, if one fails, hopefully the next one will be successful in stopping. And if it isn't, there's still a benefit to this, and that is each time a attacker has to address one of these layers and one of these controls, the attacker is spending time. By spending that time, you have more time to actually detect them, and hopefully they're going to leave more and more evidence and indication that you actually have a compromise, and you can pick that up, and then you can respond and do something to get them out of there. One thing to keep in mind here is each layer may have different effectiveness, but it's the totality of all these layers, all of the defense in depth that really makes up your security posture. That's a term you'll hear a lot, just meaning, how secure are you? Where are you secure? How secure are you? And so we just wanted to bring this to your attention. There's a number of these layers, and there's, the next question is, well, what's a good strategy around, or how do I protect these layers? So if we go to the next section here, what I want to do is, if you can go to the next slide there, Ryan. I want to start looking at, or presenting, I should say, a number of core security principles that can be applied to every layer. So these are generic ways in which you can address security at the layers that we just talked about. And if we start looking at the first one here is secure defaults. The idea behind this is that the default settings for any in-house or vended component within your ecosystem should be secure as soon as you install it. Without doing anything to change it, you have a reasonable security baseline. And the goal here is really, you have a good security baseline with no effort. I'm sure we're all aware of, to give an illustrative example, I'm sure we're all aware of default passwords on things like routers, right? And that's not secure by design, because those are well-known and well publicized, information. A better approach would be there is no password, so you have to change it immediately. Another idea around this about secure defaults would be like firewalls. And sorry, I'm using all the network examples, but they're easy and simple to comprehend. Network default secure settings for networking, deny all. So by default, that firewall is as secure as it can be, and you need to make a conscious decision to add routes within that to achieve what you want, and to make it less secure. As I pointed out here, it's a conscious decision that you make to make it less secure than what the default is. So changing firewall rules is a great example of that. Another reason why you would want to do this is, besides increasing your security posture, you're also reducing the cognitive load on your teams to know, well, what is it I have to do to actually secure this component? I need to look it up and figure out what settings I need to change from insecure to secure. Well, you don't have to do that if they're secure by default. This also saves you time as far as getting your system together before you deploy it. So your time to production is a lot shorter. And then the final point I want to make here is secure by default is a secure by design principle. And what I mean secure by design is you're designing your application, your service upfront to be secure. And so to make it secure by default means that you've had to give some thought, well, what is it that the default settings need to be in order to achieve this? And so by doing any working with thinking about how to make your application or your microservice secure, you've increased the security just by giving it attention, and it has an accumulative effect and a network effect. So if we look at the next one here, is least privilege. Least privilege is a fundamental universal security principle that applies to just about everything. And the idea behind it is any entity, any component, anything you're thinking about should only have enough privilege and no more to do what they need to do to achieve its mission, its functionality, however you want. So this is an isolation control. So if that thing is compromised, it doesn't have access to the whole world. I mean, think about it as, in file system permissions, right? You don't want to give set every file to 77, world read, write, execute access, right? You want to scope it down to what exactly a certain group needs to do to look at it or what it can access. And in cloud native world, least privilege is no different. And you need to apply that concept to every layer of the stack, to every component. And obviously that changes. There's no, universal direction. It's just, you need to think all the time, am I only giving it permission to do what it needs to do? So if we look at cloud native applications, let's say, or in a cloud native orchestration system like Kubernetes, this includes things like creating rootless builds. You want to have rootless containers. You want to minimize the number of containers that are privileged, that have root access. And so you want to keep that in mind. And so if something needs access, your first thought shouldn't be, well, we'll just make it privileged. You should look at what real access it needs and try to limit it. This can be taken to the next level with the idea of mandatory access controls, implementations like SE Linux and AppArmor, where you could really lock down and have the permissions actually enforced by the kernel. And then the other thing is, if you have to give privileged access to a container, you can also, through seccomp, control what syscalls, what root access that privileged container can have. So maybe it doesn't need all the ability of a root role. Maybe it only needs to, say, access a network port that's below, in the restricted area that only a root process can do. And so you can give that container permission to do that, but nothing else. And this is the idea, that's a very, very specific targeted example of how least privilege can be applied, and to some of the thinking you should use when, building your systems or securing your systems. If we look at the next principle. Okay, so this one is a little more, what was I going to say? A little more, I want to say fuzzy, but that's not a good word. This is more the idea of an organizational approach to doing security. And the problem is security is a cross-cutting concern. It involves more than one team. It needs to be a first-class citizen with all those teams in order to really achieve your goals. And so that means teams need to work together. And we've seen this. This is the extension of, a trend we've already seen before. We had, developers developing things, throwing it over a fence. Then the operations guys get it. Then they need to, deploy it, put it in production, figure out how to, set the settings and go back. And so that created the whole culture around DevOps. Well, DevSecOps is just the next step where now security is a first-class citizen. We're involving it at all steps. So now the developers need to be working with the security team. The security team needs to be working with the developers and the operations. Because when a prime example is to fix a vulnerability, the vast majority of vulnerability fixes are code changes. And those are not made by the security team. Those are made by the developers. And they need to work hand in hand to understand the risk, what needs to be done. There's options about how you could do that. And so needs to be together as a team. And as a team, they need to be accountable for the outcome, the security outcome. You can't have finger pointing saying, well, I didn't know that security wanted this, and security saying, well, developers aren't doing this. You need to be working as a team. And that brings us to the third point where I've been hinting at it all along, is this idea of shifting left. This is so paramount importance right now. Developers need to be involved in the security process. They need to understand that they have a significant role to play. For example, for the simple case of just vulnerabilities, they need to be looking at those and trying to eliminate those before it gets into the pipeline. Ryan was talking about how, pushing it left and how you can find them earlier. You're going to save money. You're going to save time. and effort. And this all starts really with secure design. You need to start designing your application with security in mind. Security is baked in, it's not slapped on at the end. So when you start this, it makes everybody's lives easier. If you don't have vulnerabilities to start with, you're not having to find vulnerabilities later in the pipeline and then go back, fix them, reintroduce it into the pipeline. Finally, hopefully this is an obvious thing, but I just want to mention it anyway. The rest of the organization needs to start thinking of a security mindset as well. I mean, social engineering and phishing attacks are a prime way of getting credentials. And credential stealing is a prime way to get into systems. That's the real hacks these days, or still is the real hack. And so making the rest of the organization aware of what can happen, what attacks are happening, what's the trend or things that are moving, just helps overall and just increases the security posture of your organization. If we look at the next principle here. Okay, so what we did here was combine both GitOps and automation into one. They are, loosely related, but it made a good idea to address them both at the same time because there's some overlap. The first point here is to leverage GitOps. Just by using GitOps, you've increased your security posture without even talking about security, just GitOps in general. Automating your deployments. This way you're going to have reproducible deployments. You're not going to have errors. You're going to be a lot quicker at deploying, responding to, say, a patch or a vulnerability. And because it's being done by software, you're not running the risk of having a adversary take over an account and then doing nefarious things with that account instead of just deploying things. So there's a number, just like I said, just using GitOps. Now you can take it to the next level where you're using GitOps to actually manage your security and manage your deployments of configurations, of security configurations. This could be things like not just network devices, but identity and things like that. And it can also do a lot of stuff with policy as code. So Ryan mentioned things like OPA and emission controller policies and things like that. That can be automated with GitOps as well. Nice thing about that, you have version controls. You can roll back if you make a mistake. You have evidence for audits and things like that. Now let's talk a little bit about automation. So definitely look at ways in which to use automation and automation frameworks to actually, achieve your security functions. So we talked about infrastructure as code. Well, that also means that security configurations are code. And that also means that you can actually deploy and put those out with automation tools. You can automate things like scanning, reporting, provisioning, services. And then finally, the next level up is to automate, once you discover you have an incident, to automate the response to that incident. And this is being very popular by security orchestration, automation, and response systems, or SOAR systems. Very popular acronym that's being thrown around. I just wanted to, obviously there's a choice of whether your organization wants to look into that. But at the basis of all of this is it's just a SIM with automation applied to it. So the SIM is finding events, and then you're creating automated responses to it, and that's what creates SOAR. So just a little dispelling some or clearing up some confusion around that. And again, some real benefits to it, but of course, that's another level of sophistication. So if we go to the next slide. So zero trust. This is even a bigger buzzword than SOAR was. I mean, this really deserves its own talk. This is such a deep subject. But let's just kind of, just touch on the real major salient points here. The whole idea behind zero trust is the idea that we've, Ryan mentioned it before in the beginning, classic perimeter security. I have a moat, I have a VPN. If you're outside of the VPN and you're the enemy, if you're inside my VPN, you're okay. You're a good guy. You can be trusted. Well, as we've seen with so many hacks and attacks these days, lots of people are inside your network, even if you don't know it. And so the whole concept now is never trust, but always verify, no matter who it is and where it is. So just because you're inside the network doesn't mean that you should be given full access to everything. So the tenet here is that every entity, everything that is trying to access some resource needs to have some provable identity. That's either like a key or a token. That token has been granted to that entity through some chain of attestation, which is a fancy word for saying, you started with, say, a TPM boot, and then it went to your trusted CA, which created a trusted certificate that you're now using to access things. And that proves your identity of a trail, right? And the beauty of this is that now you have a true identity, and now you can assign permissions to that identity. And those permissions are at every step along the way. Just because you can access a database doesn't mean or just because you've been authenticated by the web server doesn't mean that you automatically are granted access to the database. You need to verify against the database. This is the core concept behind it. And the key thing that it's trying to control is lateral movement. I've compromised one thing. It has access to, say, a certain box, but now I want to get access to another box or another service. And that's how, attacks happen. They just kind of move around, escalate privileges to get to where they are. Some real life implementation examples of zero trust architecture, microsegmentation. So within Kubernetes, you can create network policies in which certain containers can only talk to other containers. So, this web server can only talk to the database container, and that's it. And if somebody gets into that web server and they try to go to another container, Kubernetes will block it. Mutual TLS, not only having to know that the server or the party that you're connecting to is who they are, but also that party knowing that you are who you say they are. So the client, knowing that that's the thing. There's a number of identity management standards out there like SPIFFE and SPIRE. Again, too much to talk about in this slide. Encourage you to take a look at some of those solutions. So now let's talk about quality assurance. How do you assure that you're getting quality and continuing to have quality? So obviously, continuous assessments. You need to do regular security audits. You want to automate your scans. You want to do vulnerability assessments on a continuous basis. Just because it was secure today doesn't mean it's secure tomorrow. What happens is I had a 0 day in my system yesterday. Today, that 0 day has been discovered, and now it's a vulnerability. So I need to keep doing it. It's not one and done. Continuous compliance. Ryan talked about this as part of your pipeline. But if you need to have something, if you're, say, in a regulated industry and you need to adhere to a certain compliance standard, or if your organization has adopted one, you want to know that the container you built is compliant before you do the pull request, as opposed to later down the road, just as you want with vulnerabilities. Some cloud-specific compliance standards that probably should be aware of and could use to increase your security posture. I mean, these standards are a great place to start. Are things like the CIS benchmark for Kubernetes. You have the NIST standards. 853 is just a general one. 190 is container specific. 218 is about the secure software development framework. So that's not really so much about the runtime or the infrastructure, but how you build stuff that runs in it. And then finally, my pet project here is the Secure by Design paper that CSIS wrote. I put a star in it because it's not really a standard, but something to keep in mind. And there's still industry compliance standards that apply to the cloud just as they do to hosted environments. So PCI and HIPAA, that still applies to your cloud native world. You still need to make sure that if you have to be compliant with PCI or HIPAA, that your cloud environment and everything in the ecosystem implements any of the controls that they stand. And they do have cloud specific controls too. So keep your eye out on that. We go to the next thing. So on the thread of assurance and compliance, one area that's been kind of like a specialty area that I think needs to be moving a lot more left is the idea of threat modeling as part of your design of whatever you're building. Secure by Design assumes that you're securing right from the start. Well, what are you securing and from whom and how are they going to attack you? So taking a threat modeling approach, there is kind of an informal way like, I want to make sure that, my program only has access to these files and construct them that way. That's the idea of, that's a partial threat attack, right? There's a number of techniques. Welcome you to go and take a look at and use the one you want. MITRE does have one specifically for containers in Kubernetes if you're looking for a good place to start. And once you do this threat modeling, it's a continuous loop. Every time you're doing a release, you're looking at it, trying to figure out what now is a new threat model, identifying those threats, figuring out mitigations, validating that they work, and then again, the cycle continues with the next release or the next version. One thing to keep in mind, even though you'll see some, attacks and some mitigations that have been existing for a while, in the cloud native environment, it could be different, and you should take that into account. Again, you're just going to use that and work around it. Incident response. Oh, that's good. That's good. Right. Let's go to the next one. So incident response. The big key here is that incident response means that you have an incident to respond to. So that assumes that you have observability and monitoring infrastructure in place to capture that. And again, Ryan has talked about some of those monitoring and observability tools and components that are available to you, or that should be part of your life cycle. This should be, again, this needs to be part of the infrastructure already there. And as you build your applications and your services, you need to take that into consideration and leverage those within those. Just don't rely on passive monitoring and observing. Once you do create an incident response, you need to prove it, you need to test it, and you also need to practice the response plans and procedures to make sure they do what you think they're supposed to do, and continually to monitor it. Automation of incident response, as we talked about, SOAR, or there's some other acronyms coming out recently to address the same thing. The benefit of this is it gives you a consistent response because it's programmatically built in. So you're assured that it's going to do the same response. Just because you have a different person in the SOC on that evening versus the other evening, you're still going to get things, and it's going to reduce your mean time to respond and detect it. So I see we're getting close on time here. So what do we got next?
Now we get to the fun part. Let's take a look at the landscape.
Okay, so now we talked about these principles. How do you apply these principles in all these different layers? Well, luckily the CNCF has a number of projects to address these specific concerns, features. There's a plethora of these. Just a couple things to note here. They're at different maturity levels, so different projects are different at different stages of their maturity level. Sandbox is experimental. Incubating is, it's picked up speed, has some momentum and some contributions. Graduated means it's very mature. There's lots of things in production. So keep these in mind when you look at it. But if we look, and if I just grab a couple out of here on the next slide, here's some, just pick some that you might want to, if you want a starting place. Ryan talked about runtime threat detection and how Falco and StackRox can help you with that. If you're looking for artifact signing, which is very important for supply chain, security of the supply chain, there's Notary and Sigstore. We talked about identity management and zero trust. You have SPIFFE and Keycloak. And then as far as policy enforcement, which is another layer up, actually applying security policies within your Kubernetes framework, there's a couple of options here with OPA, Gatekeeper, and StackRox. Next slide. Okay, so what do we recommend out of this rather dense talk? There's a number of recommendations, too many to list here, so I invite you to go back and look at the presentation and pick out some other ones. But the key ones are here, again, to cultivate this proactive security first culture, embracing collaboration, DevSecOps, shift left, and most importantly, secure by design up front. You can apply these cloud native security principles to any layer of the stack to achieve that defense in depth. But again, you need to apply automation to get these actually deployed and working. You need to assess this as far as your risk profile and your risk tolerance. Leverage cloud-specific compliance standards as a starting way to harden and secure your environments. Again, you need to look at your risk profile and your tolerance. Is this going to be too much given your low risk, or is it too little given your high risk? And finally, of course, you need to do continuous learning because all of it changes, all the attack vectors change, and how we do things. And then if we go to the next slide, just quickly here, security is a continuous process. It's going to be incremental improvement. It's ever-changing requirements. So it requires a feedback loop on what did I do? Did it work? What's new? How do I apply that? Did that work? Is it working? And run it. So what's the recommended next steps for starting their cloud native security journey? Leverage the CNCF security frameworks. There's communities, resources, talked about the projects, and you can contribute too. And with that,